Okay, here we go. Notes. We're doing, this section is on radicals. Radicals are well, today luckily we're going to look at square roots, right? Just normal, regular square roots. We know that we don't have to write a 2 here, but we know that there's an invisible 2 right here. There's also cubed roots, and then there's fourth roots, but we're going to look at just simply the square roots, right? Square roots. Okay, so let's start with the easy stuff that you already know. So if you have to simplify, because that's what it's going to say, right? Simplify it. Okay, number 1, what if I tell you the square root of 36? You always want to see if we can get a perfect square number here, right? A perfect square number. 36 is what? Well, why is the answer 6? Because this is 6 times 6, right? That's why you don't write a 2. You don't see the little 2 there. They don't write it because it's the first one. You don't see the little 2. But once you have 2 of the same numbers, right, multiplied to each other, they come out as 1, right? So I have a set of 2 6s here, so it comes out, and that's why the answer is 6, right? Okay, you've seen that. That one's too easy. Number 2, how about if I put a negative square root of 100? Well, negative. Well, the answer is just going to be negative, and then what's the? This is like a negative 1 multiplying to whatever the square root of 100 is. The square root of 100 is what? 10. So everybody good with negative 10? And then 3. What is the square root of? Let's see. What is the square root of 529? Anybody know that one? Well, no, not off the top of your head. That's why we have calculators, right? Everybody know how to use your square root button right there, right? Square root, right? The square root of 529. Always check when you're given a number if it's a perfect square number. It might be. Well, this one is. The square root of 529 equals 23. It's a perfect square number. You just didn't know it, right? But always check. How do you know when it's not a perfect square number? Yeah, let's say I put the square root of, remember I put the square root of 80 earlier on the board? The square root of 80 is, okay, that's when you know it's not a perfect, you'll get these decimal stuff, right? Yeah, it doesn't have a perfect square root. Okay. All right, now these. Number 4. Carlos got this one right earlier. What is 3 times the square root of 16? Or what's 3 root 16? Well, this means 3 times the value of the square, right? It doesn't say 3 plus 16. It doesn't say 3 minus 16. When there's a 3 like that, when there's any number in front of it, it's multiplying 3 times whatever the value of this root is. And the square root of 16 is 4. So really it's really just telling you 3 times 4, right? The answer is 12. Okay, number 5. What about negative 2 times the square root of 225? Negative 2 times, is 225 a perfect square root number? I don't know, let me check. Calculator. It does tell me something here. It's 15. So really this problem is saying what? Negative 2 times 15? Okay, are we done with the easy stuff? I think you guys can handle that? Yeah. Okay. All right, now moving up to these other ones. Okay, now these are the type of problems. These are going to have kind of like division. They're going to be like in a fraction form. Like the one I put over there, the square root. Let me see, how is that? Oh, this one has it like this. The square root of 9 over the square root of 25. Well, first always check, are any of these perfect square root numbers? You always check that. Well, 9 is a perfect square root number, and 25 is a perfect square root number. So, what's the square root of 9? 3. What's the square root of 25? 5. Aren't they both perfect square root numbers? Yeah. So always check that first. That's one type of problem you'll see. Okay, number 2. What if I have the square root of, let me see, hold on, let me check something. Does any one of these have a perfect square root? Always check. Yeah, the 16 has a perfect square root, but not this one, right? Not 6. You better not put 3. It's not half of a number, is it? No, it's not. But 16 does have a perfect square root. The square root of 16 is 4, right? But this one does not. If it doesn't, you just leave it like that. Just leave it like that. Only this one has a perfect square root. Yeah. If they both have a square root, then you just square root the top, square root the bottom. But if only one of them has it, just do that. Okay. Now, what about this? Oh, I did that already. Okay. What about... Did that already too. Number 3. The third type of problem, the square root of 10 over the square root of 18. Anybody know how to do this? Let's see. The first scenario, you look at them, and if you recognize the numbers to be perfect squares, if they each have a perfect square, okay, you'll get it right away, right? That's one type of problem like this. The second type of problem has, well, again, you look and see if which one has a perfect square root, and one of them does, right? And so that one does, and so you change it, and that one doesn't, so you just leave it the way it is, right? That's the second scenario. Now, what's wrong with this one? None of them have a perfect square. None of them have a perfect square. Okay, this is what you can do, or what you're gonna need to do for something like this. When none of them have a perfect square, you can do this. You can actually write them, since they both... Yes, very good. Since they both have square roots, you can write it like this and write the fraction under one big square root like that. And what did Samantha say right now to look at this fraction and do what? Reduce. Can you reduce a 10 over 18? Yeah. What would that reduce to? See, now you got, now you got the square root of 5 over 9.
9 could be reduced.
And now you can put it back the other way where you just look at them each individually. Now you can look at them individually and say, I mean, you could have reduced here too, but then the square root of 5. See, now you look at them separately or go back to giving them each their own little square root, right? And now which one does have a square root?
9.
The 9. So what's the answer for this one? Square root of 5 over 3. You guys see that? Okay, let me do another one similar to that. Is that okay? Does that make sense? I mean, we kind of could skip this step. We can skip this step and just kind of go from here to here. Can you guys see that? Can we avoid these two and just say, hey, what if I just look at those numbers and just reduce them like that? Is that better, you think? Okay, we can do that. Okay, let's look at another one. Similar, number 4. What about the square root of, I just had one right now. Oh. That's actually an easier one. Two doesn't have a square root. 18 doesn't have a square root. But if I kind of look at them and try to reduce 18 divided by 2, can 18 divided by 2 reduce? What's 18 divided by 2? Just 9, right? Isn't it just 9? And doesn't 9 have a root? Oh, 9 is a perfect square root. What's the answer for this one? 3, right? It's just 3. All right. How about I just had one, number 5. Let me think of a good one. I just had one and I lost it. Let me go with eight and what am I gonna do here? Yeah, go ahead. How about that one? Let's see. Jaden? What am I going to do here? Can an 8 and 100 reduce? By 10? What the? Oh, yeah, you're right. Actually, 100 is a perfect square root. By 10? 10 doesn't go into 8. Oh, that shouldn't have happened here. Actually, yeah, I know this is a perfect square root, but actually, did you guys reduce by 4? If you reduce by 4, you'd get 2 over 25. If you reduce divide by 4, you'd get 2 over 25, and the answer is root 2 over 5, huh? We got it? Last one? Okay. What about square root, square root? $45. What's gonna work here? And 60. That doesn't have a square root. That doesn't have a square root. So reduce. Anybody know what number is the greatest common factor to reduce a 45 and a 60? By 5? Then you'd have to do it again, then you'd have to do it again. So I'll tell you, it's 15. 15 can go into 45 and 15 can go into 60. So let's see, 15 times 3 is 45, and 15 times what? 4 is 60? Yeah. So when you reduce, this is going to be what? 3 over 4? And that's the answer like that? No, because one of them left is a perfect square root. Final answer is? So if anything, these are the ones that are probably the more newer ones for you. The earlier ones that we did back up here, I think you're gonna be okay with these. All right, but we're gonna start looking at stuff that you probably didn't learn before. Okay, there it is.